Hello children, welcome to the geography class. In this class, we are going to discuss about rotation and revolution. Before that, let's see the syllabus. In this chapter, we are going to discuss about rotation of the earth, its direction, speed and effects. We'll also learn revolution of the earth and its inclined axis, its effects and variation in length of day and night, and seasonal changes with equinoxes and solstice. In ancient times, people observed the movement of heavenly bodies, especially the sun and the moon, with great interest and anxiety. They noticed that the sun rises in the morning, reached its highest point in the sky around midday, and in the evening it sets in the west. This made them believe that sun and moon moved around the stationary earth. This myth was broken by Nicholas Copernicus, a Polish astronomer, in 16th century. He proved that the earth only appeared to be stationary. Actually, it not only spins on its axis but also moves around the sun. Thus, the earth experiences two types of motions: rotation and revolution. Many phenomena on the earth, like day and night, seasons, winds, and ocean currents, depend on these motions. Rotation is the spinning of the earth on its axis from west to east once in 24 hours. The axis is the imaginary line passing through the center of the earth as it does on the globe. The two end points through which the axis passes are known as the North Pole and the South Pole. The axis is tilted at an angle of 23.5 degrees from the vertical. This means that if a line were drawn parallel to the plane of Earth's orbit, the axis would make an angle of 66.5 degrees to this line. Following are the characteristics of rotation. First, direction. The Earth completes one rotation from west to east on its axis in 23 hours, 56 minutes, 4.9 seconds. Roughly, it takes 24 hours to complete one rotation. Second, inclination of axis. The Earth is always tilted in the same direction as it moves round the sun. That means, Earth is tilted towards the pole star. The angle at which the Earth is tilted is known as the inclination of the Earth's axis. Third, speed. The speed of the Earth's rotation at the equator is 1670 km per hour. The speed decreases towards the poles. Effect of the rotation of the Earth. Due to the rotation of the Earth, half of the Earth's surface receives sunlight from the sun and experiences day. The other half of the Earth's surface is turned away from the sun and it is in darkness, thus experiences night. This happens with precision and progression and not suddenly. The time when the sun begins to cast its light in the sky is known as dawn. At noon, the sun is overhead. At dusk, it is twilight and the sun seen disappearing in the sky. And at night, it is completely dark. Duration of the day and night is not equal at all places on the earth because of the inclined axis. The length of days varies with respect to the season as well as latitude. Sunrise and sunset are caused by the rotation of the earth from west to east. So, the sun appears to rise in the east. The part of the earth that moves from darkness into the sun rays experiences sunrise, and when it moves away from the sun rays, it experiences sunset. Once the direction of the rising sun is known, it is easy to find out other directions such as west, north, and south. Next is Coriolis effect. The Earth's rotation deflects the air and the ocean currents towards the right in the northern hemisphere and towards the left in the southern hemisphere. Such deflections are due to Coriolis effect. Coriolis effect refers to the force experienced by any object moving over the surface of a rotating body such as the Earth. Fourth effect of rotation is that the sun, the moon and the stars seem to move from east to west. This is because the Earth spins from west to east. This effect is similar to what one experiences while looking at trees from a moving train. Fifth effect of Earth's rotation is centrifugal force. Centrifugal force is an apparent outward force that acts on a rotating object. It is always directed outside. The rotation of the Earth has resulted in the flattening of the Earth at the poles and bulging at the equator. Thus, the shape of the Earth is not a perfect sphere but an oblate spheroid. Next effect is difference in time. The difference of time on the Earth's surface is also due to the Earth's rotation. The Earth completes one full circle in about 24 hours. Thus, it covers 1 degree in 4 minutes. Next effect of Earth's rotation is gain heat and lose heat. The side of the Earth towards the Sun constantly gains heat, and the side away from the Sun constantly loses heat by radiating it into outer space. Now let's learn about the effects of inclined axis on the day and night. The duration of day and night is not equal in all the places. It is because of inclined axis. Suppose if the Earth had a vertical axis, then the length of day and night would have been equal at all the places on the Earth. Second, the duration of day and night at the equator is always same. It's because the vertical rays of the sun falls directly on the torrid zone. Hence, all the places will have same day and night at the equator. Third one, if the axis of the Earth was vertical. If the axis of the Earth was vertical instead of inclined, places on the Earth would have the same temperature throughout the year. The time of the day. The time of the day at any place is determined by the height of the sun in the sky. There would not be any season. If the Earth did not revolve around the sun, even then with its inclined axis, there would be no seasons. Now let's understand the effect of the inclined axis on the season. The path of the Earth around the sun is known as elliptic. It passes through the center of both the Earth and the sun. The inclination of the axis has important consequences. Because of its tilted position, each pole is inclined alternatively towards the sun twice a year. When it is summer in the northern hemisphere, it is inclined towards the sun, and the south pole is away. Hence, southern hemisphere experiences winter. Similarly, during winter, the north pole is away from the sun, and south pole is inclined towards it. Hence, it is summer in the southern hemisphere. If axis was perpendicular to the place of elliptic, every place on the Earth's surface would have had 12 hours of day and 12 hours of night, and there would have been no seasons. Then why we do not feel the motions of the Earth? Rotation and revolution are the two chief motions of the Earth. If we were to feel these motions, it would make life uncomfortable. The force of gravity keeps everything attached to the earth. This keeps all objects at rest with reference to the motion of the earth. Using this principle and Newton's first law of motion, which states that a body remains at rest or uniform motion unless compelled to change that state by an external force acting on it. So that is why we do not feel the motion of the earth.